Okay, so we can now go ahead and solve this problem. So we have been given the particle is forced to oscillate under SHM, and when the driven frequency is half the natural frequency, the resulting amplitude is A. That's what it's given. Okay, so let's quickly write that down. So when the driven frequency, when the driven frequency is equal to half the natural frequency, so I'm going to write in terms of angular frequency because I'm accustomed to that. The amplitude is A. Okay, that gives you the amplitude as A. And we have, if the driven frequency is now tripled, calculate the amplitude and neglect damping. Oh, that's a good news. Okay, so that's what we have to figure out, and it's a steady state. Okay, so we need to know what happens if driven frequency is now, so let me call this as omega d dash, is now tripled, that is 3 times omega naught by 2. What's the new amplitude? Okay, alright, so for this we're going to use the fact that the amplitude when it has been driven is equal to f naught divided by m into omega naught squared minus omega d squared. Omega naught squared minus omega d squared. Okay, so when omega d is omega naught by 2, the amplitude turns out to be A. So A equals f naught divided by m into omega naught squared minus omega naught squared divided by 4, and that gives me f naught divided by m times 4 minus 1, 3 omega naught squared times 4. Okay, let's call that as equation number 1. So what's going to happen when the driven frequency is 3 omega naught by 2? Alright, so let's call that amplitude as A dash, and that's going to be f naught divided by m times omega naught squared minus omega d squared. Now omega d is this number, so that's 9 omega naught squared divided by 4. That is f naught divided by, let's see, you get minus 5 omega naught squared into 4. Okay, and that I will write as minus 4. Yeah, it's minus 4. Okay, minus 4 f naught divided by 5 m omega naught squared. That's equation number 2. So to solve this, all we have to do is divide the two equations. So A dash divided by A turns out to be equal to, let's divide these two, you will get f naught, that cancels out. So you have in the numerator this guy 3, the denominator this guy 5, and a minus sign. So A dash turns out to be minus 3/5 of A. The reason we have a minus sign is because there's a phase shift. We can completely neglect that. So when I say amplitude, we basically mean the absolute value, and that turns out to be 3/5 of the amplitude here. And what you have to see is the amplitude became worse than what it was before. It was before A, it is now 3/5 of it. It's only 0.6, 60% of that.